Okay, a frog jumps to catch a grasshopper. The frog reaches a maximum height of 25 centimeters and travels a horizontal distance of 100 centimeters. A grasshopper located 30 centimeters in front of the frog starts to jump at the same time as the frog. The grasshopper reaches a maximum height of 36 centimeters and travels a horizontal distance of 48 centimeters. A frog and the grasshopper both jump in the same direction. So for part A is as consider the frog's starting position to be the origin of a coordinate grid. Draw a diagram to model the given information. So what we're going to do is we're going to draw the x and y axis first, okay, for this whole diagram. So it's going to be my y-axis and my x-axis. And it says take the origin to be the starting position of the frog. And the frog will do a parabolic curve. And remember, it travels a maximum distance of 100 centimeters. So this point is going to be 100, 0. And it reaches a maximum height of 25 centimeters. So the y-coordinate at this maximum is going to be 25. And we know that halfway point of 100 is going to be 50. So we have a parabolic curve of the frog. And I'll label it the frog. However, for the grasshopper, it states that it starts 30 centimeters in front of the frog. So our starting position coordinate for the grasshopper is going to be 30 and 0. And it reaches a maximum of 36 centimeters. And remember, it moves forward to a maximum of 48 centimeters. So 30 plus 48 will give us 78 centimeters. So the maximum distance that horizontal distance that reaches 48 centimeters, therefore 30 plus 48 gives us an x-coordinate of 78 and 0. So we have our maximum point here. So the halfway point is 78. So basically, well, 48 divided by 2 is 24. So 24 units to the right of 30 is going to give us 54. 54. So there's our parabolic curve for the grasshopper. Oops, pen's not working properly. Grasshopper. So that's our two parabolic curves for the frog, which reaches a maximum height of 25 centimeters and maximum horizontal distance of 100 centimeters. And our parabolic curve for the grasshopper, which reaches a maximum height of 36 centimeters and travels a maximum horizontal distance of 48 centimeters. However, it starts at 30 centimeters in front of the frog. That's why we have that's what we have the starting coordinate of the grasshopper to be 30 and 0, and 48 to the right is going to be 78 and 0. Okay, now part B asks us determine a quadratic equation to model the frog's, let's fix that spelling, the frog's height and the grasshopper's height as a function of a horizontal distance traveled. So let's get to work right away. So we know that from the previous graph that we drew that the frog, the vertex of the parabolic curve of the frog is at 50 and 25, and the vertex of the grasshopper, grasshopper, my spelling sucks, grasshopper is at 54 and 36. And I'll just draw a general graph of what it looked like. So we had for the frog here and the grasshopper like that. Remember that origin was 0, 0, and this point was at 30 and 0, 0. So what we're going to do is first we're going to determine the quadratic equation for the frog. So we know that the vertex is at 50 and 25. So given the standard parabolic equation for parabola is y is equal to ax squared. So this indicates the horizontal translation and that indicates the vertical translation. So we have y minus 25 is equal to ax minus 50 squared. So we're going to use one of the coordinates along the curve of the frog, so we're going to use the coordinate of 0, 0. So we're going to use 0, 0, and we're going to substitute x as our 0 and y as our 0. So we're going to substitute our x and y points. So that'll give us 0 minus 25 is equal to a 0 minus 50 squared. And that will give us minus 25 is equal to a, and negative 50 squared will give us 2,500. So we divide both sides by 2,500. 2,500. And 25 will go into 2,500 100 times. So a will be equal to negative 1 over 100. So we're going to substitute this a value into this equation right here. So it's going to give us, well, I'll just draw a line. Y minus 25 will give us negative 1 over 100 bracket x minus 50 squared. And let's move the 25 to the other side by adding 25 to both sides, plus 25. So we have y is equal to negative 1 over 100 x minus 50 squared plus 25. So what we did was we wrote the y represents the height of the frog, which is dependent on the horizontal traveled here, okay? So we have our equation for the frog. Then now we'll determine the equation for the grasshopper. So we know the vertex is at 54 and 36. And we know the starting position of the grasshopper is going to be at 30 and 0. And we're going to still use the standard equation of a parabola. So y is equal to ax squared again. And let's start with the horizontal and vertical translation. So that gives us y minus 36 is equal to a x minus 54 squared. And now in order to solve for a, I'm going to use the starting position for the grasshopper and use its x and y coordinates, substitute those values. So we get 0 minus 36 is equal to a 30 minus 54 squared. And that gives us negative 36 is equal to a negative 24 squared. And negative 36 is equal to, well, negative 24 squared gives us 576. So we're going to divide both sides by 576 to solve for a, 576. And 36 goes into 576 16 times. So a will be equal to negative 1 over 16. So we'll substitute the a back into that equation. So we have y minus 36 is equal to negative 1 over 16 bracket x minus 54 squared. And we're going to add 36 to both sides. So y will be equal to negative 1 over 16 x minus 54 squared plus 36. So here is the equation of the grasshopper, where y represents the height that the grasshopper reaches, dependent upon the horizontal distance traveled. Okay, so the important equation is these two equations. Let's start here. Our equation for the frog and equation for our grasshopper, which we'll do on our next page. Okay.